Lagrange Interpolation exercise. Example 4.3. Find the Lagrange interpolating polynomial for the data. Hence, evaluate f at 3, f at 5, and f at 6.5 if applicable. Okay, for step number 1, you need to construct a data in a tabular form. So meaning that you have data here, so you need to transfer it into a table. So in this case, this is our x, 0, 2, 4, and 6. So 0, 2, 4, and 6. So the data for 0 is actually 1. So put here 1. 2 is minus 1. Okay, tabulate here. 4 is minus 1. And 6 is equal to 1. Next, we will find the Lagrange at 0, 1, and the rest. In this case, we have 0, 1, 2, 3, meaning that we have Ln until L3. So we will find L0, L1, and L2 and L3. So L0, we will use the formula as previous exercise. So key in the value, replace the value here, okay, for L0, L1, and L2 and L3. I have skipped the L2. Next, we will construct the polynomial by using this formula. So we have our L here and our F value here. So this is polynomial 3. So this is the formula. So fill in the value and then you will have a general equation here. So now we will find our evaluate data. So we will test first at x equal to 0. So in this case, it is equal to 1. For f0, is it correct? Yes, it is correct. It is equal to 1. Okay, just to double check. Okay. So next we will go to the evaluate. Then we need to evaluate f3, f5, and f6. So what we do, are we going to use the previous formula here, and then replace the value x with the value that we would like to find. So this, in this case, this is 3, and then you will have minus 1.25. Please try this exercise. Make sure do not be careless when you key in your calculator. And this is for P3, and you should have minus 0.25. In the last x value is 6.5. If you refer back into the data, you can see that the range of x is only from 0 to 6, meaning that if it is exceed the range, you cannot use interpolation in your finding a missing value. So for 6.5, it is not in the interval. So this example, we cannot use interpolation value to evaluate f6.5. So we will go to the next example. Example 4.4. Given the set of data shown in this figure, approximate f at 1.5 using Lagrange interpolating polynomial. So as usual, the step 1 is for you to construct this data in graph into a tabular form. So make sure you have everything in a correct manner. So this is actually x is at 1 and 2. So you can see that this is our 1 and this is our y at 2 is actually our fxi. So this is our y. So this is 2 for our fx. Okay, and the rest you can plot. This is 2, 2, and our y f at or fx is 3. Okay, and we have our 3 here, and y is 7. So we have that. Now we will proceed. Okay, after we have tabulated the table, we need to find the value for the Lagrange at L0, 1, and 2. Okay, in order to do that, use the formula. And then we will get the value of 0.375, 0.750, and minus 0.125. So in the next step, we will evaluate this value. So we will use the formula here, and then we will evaluate the 1.5. By using the formula that we have here, so we can enter L0 is 0.375. So we have here, so we have our f1 at the f at 1 is our value is 2, so we key in here 2. So our L1 here is 0.75. So this is minus 0.75. And then we have our f2 is 3, so we put here 3, and the rest. So you should have 2.215. There are weaknesses when applying Lagrange polynomial interpolation, such as it involves too many calculations. If the number of point data is given is big, so if some data is added or taken away, the existing calculation cannot be used in a new calculation. So that is for the example 4.4. Please try. Thank you.